So, who found something, you can't figure out what in the heck I was doing on the answer sheet, which could be wrong? Yeah?
It's not even that, it's just, you use it over 14 days. Number 14
It always looks like that, yes, and this always. Did you just say this one?
14.
So it always looks like this, basically.
So,
And it always.
your job is to prove that one side is the same as the other side. Okay? So, I'm gonna, I see there's stuff I can do over here, I'm gonna mess around over here and see if I can somehow get this shrunk down to this. Now, there are a couple things I just observed, because my eyes are open, right, and I'm paying attention. These are all signs. There aren't any cosines over there. So if that's my goal, then I better get rid of these cosines.
Yes.
So I know, because on my list of things to know, I know that sine squared plus cosine squared is 1. Which means cosine squared is the same as what? 1 minus sine squared. So we're going to take that cosine out, replace it with 1 minus sine squared. On the top and the bottom. Now, obviously there's some arithmetic to do here. Distributing, qualified terms, and so on. So we'll take care of that. Just clean that work. So I've got negative 3 sine squared plus 5 sine minus 2. Now that's where I'm headed. That is clearly smaller than this, right? So I gotta get rid of something. I get rid of things by canceling, and in order to cancel, I have to factor first. Now, if the negative up here is bothering you, somebody was in here for office hours yesterday, really struggling trying to factor this, remember, you can multiply top and bottom by negative 1. And then you don't have a negative anymore, so now we'll have 3 sine squared minus 5 sine plus 2, and sine squared minus 1. Now, the only way to cancel is to factor first, right?
Where'd you get the negative 2?
Or is it supposed to?
3 minus
Okay.
5, collecting like terms.
Oh.
So now we can factor, hopefully. We could have factored here. It doesn't matter. I just know we were having trouble yesterday with that. So let's see, I need a minus and a minus. That works. And then what's my bottom? That factors too, because that's the difference of squares. And lo and behold, once we factor, we can cancel, and then we're left with what we wanted to be left with. Okay? So again, every one of these problems is going to be different, you guys. Everyone's going to be different. So what was going through my mind? Got to get rid of these, and got to somehow cancel something out. If that's my goal, right there. All right, who else? Chris? 10. Now this is a calculator problem, not because it's hard, but because the sides of the triangle, when I draw a picture of 10 minus 4i, it's over 10 down 4, are those ratios that I know, like, are those 1/2s and root 3's over 2's and all those numbers from a unit circle? No. So I need a calculator to help me figure out what this angle is right here. First of all, let's understand what we're doing here is finding the polar form. Polar form is our cosine theta plus I r sine theta. That's polar form. Has the r and the theta and the I from the original number. So here's r. What's r?
Square root of 1.
Square root of 116. Does that break down? It divides by 4. 29, so 2 root 29. Is that what you said?
Yeah.
So r is 2 root 29. And now I need theta. So I'm gonna go to my calculator, because I don't know what that angle is without a calculator. And what am I gonna type in? Second tangent, 4/10 or negative 4/10. This angle right here, this angle is 0.381. In polar form, we need the standard position angle between 0 and 2 pi. So, that's 0.381, that's fine, but I need this one. This is the one that's gonna go here, so how am I gonna find that? Minus 2 pi it, 2 pi minus it, whatever. So this is 5.903. And there's your answer. Now, if these had been different numbers, could I have done that problem without a calculator? Yeah.
How do you find 0.381?
Second tangent 4/10. Tangent 4/10. All right, what else?
No, that's not. Here, with the other.
What else could you not figure out what the heck I was doing? McKenna? 17 was not the upside down one. So f of theta is 4 cosine 2 theta. And I know that I'm between pi and 3 pi over 2. So what I'm gonna do, McKenna, is I'm just gonna put in those two values. I got a picture in front of me, I'm just gonna see if I can tell from those. So if I plug in pi in my equation, I plug in pi, what do I get? And what's the cosine? Is this sine or cosine? Cosine. So what's the cosine of 2 pi? 1. So that's just gonna be 4 pi. So when I look at the pictures, 4 pi is right here. Okay? Alright. Now let's put in 3 pi over 2. What happens when we put in 3 pi over 2? We get cosine 3 pi, which is the same as cosine of 1 pi, which is negative 1. So this is negative 4. Where does that point get plotted? That point gets plotted at 4 comma pi over 2. So when I look at what I've been given, only one of those graphs contains those 2 points. Would you agree? Say. Yeah. The picture is of 4 lead rows. And almost together it would look like that. Okay, all right, what else? Anything else we need to, yep, 18. This one is negative 3. Sine 3 theta. And, okay, and he just wants to know which of those could be the graph. Okay? Now, first of all, they're all 3 lead roses, which is exactly what you would expect, right? So let's I don't know, let's pick a number. Catherine, let's do some evaluating here, and let's see if we can find a point that's on one of these graphs. So, for example, what if we put in 0? What if we put in 0? What do we get if we put in 0? What's the sign of 0?
Isn't that pi over 2 or something?
Sign of zero
No,
is
the
zero.
sign of 0. So think of your unit circle, here's 0. What point is that?
Oh, 0.
The sign of 0 is 0. So 0, we should be at the pole. All right, so that is gonna rule out question B. Is that a B? The second one, up in the top right corner. It's gonna rule that one out because that has pedal out here. And this one's not going to, this one's at the pole, so we're gonna throw that one. All right, let's pick another number. How about, what happens if we pick pi over 3? Let's pick pi over 3. Okay, so pi over 3 would be sine pi, which is 0. All right. Pi over 3, I have to be at 0. So that's gonna rule out A. Look at picture A. You see why it rules it out? Because at pi over 3, that has an R value.
Yeah.
Catherine, do you understand what I'm saying? No?
No.
Okay. Look at picture A. It has a leaf at pi over 3.
Yeah.
That means that point is 5 comma pi over 3 or something. I don't know what that R value is. It's too small, I can't read it. But whatever it is, there's a pedal there. What's it supposed to be there?
0.
Yeah, so it can't be that picture
Okay.
because that's not 0. That's 5.
Okay.
Okay? So let's pick another one. How about pi over 6? Pi over 6 would give me sine pi over 2, which is 1 times, so that's negative 3 pi over 6. Where's that one gonna get plotted? That one is gonna get plotted at 3 comma 7 pi over 6. Now, I've already ruled out A and B, so I'm looking at C and D. Do I have a pedal at 7 pi over 6 in either one of those pictures?
C.
C, the answer's C. So I kind of went around, I just randomly picked points. You could literally pick a point on each graph and check to see if it worked.
Okay.
I was just randomly picking.
So, I think I chose D on that one, and I thought that, or I don't know why my head went this, but when I saw a sign and I saw the negative with it being on the y-axis, so it's incorrect to think like that.
Well, I think there's some benefit to that, but let's say you think, so that's your gut feeling. I think
Yeah.
it's D. All right, so what's that point down there? That point down there would be,
0, -1, or what?
no, in the picture, it would be 3 pi over 2,
Oh,
comma 3.
Mhm.
Okay, so check your equation. You're shooting for 3 pi over 2. That's what you think that, okay. So let's put 3 pi over 2 in here. What do we get if we put in 3 pi over 2? We get 9 pi over 2. Well, 9 pi over 2 is too big. So what is that the same as?
Pi over 2.
Negative 3 sine, wait, if we take out 4 halves and 4 halves,
Pi.
that's the same as pi over 2? Right? And what is the sign of pi over 2? 1. So this point, when you put in 3 pi over 2, it actually gave you negative 3, which is not the same as what you wanted.
Okay.
So actually, that could have helped you, because if you look over at C, that has a point up there. So yeah, that's the one. All right, anything else?
Can you do 12, please?
12? All right, so this factors. All right, so I factored it, and I have found my important numbers where the cosine is a half and the cosine is 1. All right, given? Okay. So now I'm going to go ahead and sketch my cosine curve. And I'm going to identify the places where the cosine is a half. Now that would be right here. Remember, this is 1. So this is where the cosine is a half. Here and here. Well, what angles have a cosine of 1/2? Pi over 3 and 5 pi over 3. Okay? Now, what angles have a cosine of 1? 0 and 2 pi, but I'm not counting 2 pi. All right? So, I am multiplying these two things together, and I want the outcome to be positive. How do I multiply two things together and end up positive?
2 negatives or 2
Both
positives?
positive or both negative, right? So positive means above. So I need to be positive, I need to be above the green. Here's my green line. I need to be above green and above red. Well, the only thing that is both above green and above red, and that's or equal to, would be this point right here, right? So the answer to that case is just x equals 0. Now, I need to be below green and below red. So below green is basically the whole curve, and then below red is here. So the answer to that one is everything from pi over 3 to 5 pi over 3. So your answer is those two things put together. Either x is 0 or x is in this interval right here.
You have to write it as x equals 0, but then instead of 0.
We write x equals 0, comma.
I mean, like, what do we write? Pi over 3, 5
I think
pi
I'd
over
write
3.
0. I think I write x equals 0. I don't know. You gotta have that in there as part of the answer. All right. Now, what I want you all to do, because I'm gonna now knock your socks off, because I made yet another review sheet. So, I need you to go back to Schoology where you were. Extra practice and review. There is now going to pop up an additional review. Okay? So additional review.
15 on the paper is just cosine 2x equals cosine. But on this, it's 2 sine squared. No, 2 cosine x minus 1. Was that like a mistake or did I not?
That's the formula for cosine 2x. You have to memorize your formulas for cosine 2x. They're on your need to know sheet. You gotta memorize them.
Over
So, the girls just asked a question. Let's take a look on this additional review at problem number 5. Because we haven't done this one yet. So somebody tell me what's wrong with this equation. Why is it problematic? Cosine 2x. You cannot do a problem when you have x's and 2x's. If they're all x's, great. If they're all 2x's, great. But you can't do a mix and match. So what are we gonna have to do? No, don't do anything until you take care of that problem. There's a formula on your need to know sheet. There's a formula for cosine 2x. There's actually a couple of them. The one we're gonna want in this problem is 2 cosine squared minus 1. Why am I choosing that one? Because we're already working with cosines?
Yeah.
Now, I can start doing stuff. So now, I can get everything on one side of the equation, because it's a quadratic, so we get everything on one side. So I'm gonna have cosine squared, minus 2 cosine, minus 3. Now what? Now I can factor.
Number 5 on the extra review.
So it says cosine is 3 and cosine is -1. Now remember, your answer is the angle, so I want to know what x equals. Where does the cosine equal 3? Never. Guys,
Pretty sorry.
cosine x over r, can that be 3 over 1? No. Where does the cosine equal -1? There's your answer. The only answer to that problem is 5. Now, you are not going to see that problem again. What skill do you need to take away so that you can do the next problem? You gotta know, you gotta get rid of that 2x. So if it's a sine 2x, you're gonna replace it with 2 sine cosine, whatever, you gotta take care of that. And then just go from there. Okay? Alright. Alright, so let's see, what would be most productive here? So randomly have some people come up and do some of these on the board,
Get up there.
or I can stand up here and do some, you can do them on your own, on your paper, what's the plan?
We do them on our own and then ask questions about it.
Yep. Before you ask me though, before you ask me a question, I need you to ask around.
I will ask around. Always.
Okay?
You gotta get them.